runs in a bearing which is rotating at 450 rpm. Bearing is subjected to a normal load of 3.5 kilonewton. If the value of minimum oil thickness required to ensure hydrodynamic lubrication is 0.015 mm, suggest a suitable oil. This part we completed yesterday. Given the ambient temperature is 40 degrees and the oil temperature is not to exceed 90 degrees. It should be below 90 degrees. Then the ratio for C by R is given as 0.001. We have to also determine heat loss. Due to friction. Comment whether external cooling is required. Comment if external cooling is required. Given bearing is well ventilated. What is the meaning of this statement? What is the meaning of this statement? Even if the bearing is well ventilated, when would you need an external cooling? Also calculate oil flow rate. Kaustubh? Sarthak? What is the meaning of this statement? Comment if external cooling is required if it's given bearing is well ventilated. What is the meaning of this?
Not enough heat is dissipated.
Yes, which means the amount of heat generated is more than the amount of heat dissipated. And since the oil temperature has to be maintained less than 90 degrees, we might require external cooling. So we have to check if heat generated is greater than heat dissipated. You are right. Okay, so this problem we have already started solving by assuming an L by D ratio of 1.2. You can as well assume L by D as 1.3, but normally we'll go with L by D 1.2. Then the average pressure, this is the load upon L by D. Since you know D, L by D we have assumed, so we know what is the pressure value. And this you calculated as 0.81 MPa. Then the value of C by R, this is given. And from C by R, since radius is half of the diameter, you also know what is the clearance. And the value of clearance came out to be how much? .03 probably. Then this Sommerfeld number S is Z, viscosity N is speed in RPS, so we convert 450 RPM into RPS. by pressure in pascals R by C whole square. Small r, capital R, whatever you want to use. Now here N is known, P is known, ratio of C by R is known, so R by C is also known. We have to find out which oil should be used, which means we have to find out the viscosity and then we have to comment which grade of mineral oil is required. Now you cannot have two variables for solving this one equation. So what we are going to use is we are going to find the Sommerfeld number from the graph of, we have a graph for Sommerfeld number versus H minimum by C. We know H minimum, we know C, for which we are referring to L by D 1.2. So we have L by D 1, L by D 2. So approximately for L by D 1.2, we've got the value of Sommerfeld number S as how much? The first column is for 10 raised to minus 2. So every time you have to multiply it with 10 raised to minus 2, then it is 10 raised to minus 1 likewise. So you are getting a value 1.6 10 raised to minus 1, which gives a value of S as 0.16. From the table you are getting it as 1.6 10 raised to minus 1. So you have to be very careful when you are reading the table, since you are referring to the soft copy, the chances of committing an error is high. I strongly recommend to come to physical classes with a physical data book. That would be easier. Even in your NSEM exam, which will be in a physical mode, you will not be allowed to carry mobiles. And so you definitely need a hard copy of design data book. Okay, so convert into consistent units and give me the value of Z. Everything known, S, N, P, R, and C known. Give me the value of Z. You got this as 0.016 Pascal seconds, which is 16.2 millipascal seconds, and the graph of viscosity versus temperature, referring to the graph viscosity versus temperature, you get for viscosity 16.2 degrees and for temperature 90 degrees, approximately 90 degrees. We are selecting the oil SAE 40. Next, we have to find out what is the heat generated and what is the formula for heat generated. What is the formula for heat generated? U into V into W. So for getting heat generated, we must know what is the coefficient of friction. Load is known, velocity is known, load is known. It is given as 3.5. Velocity is pi d of the journal n by 60. So you gave me the value of velocity here. Now for getting the value of mu, we'll be referring to another graph. Now this will be the graph for mu r by C versus Sommerfeld number, which is given on table 134, figure 13.3. Refer the graph, which is figure 13.3, As per my design data book by Shivalkar, it is page 134. This is the graph of mu r by c on y-axis versus Sommerfeld number S. So for S as 0.16, which is 1.6 10 raised to minus 1, L by D between 1 and 2, give me what is the value of mu r by c. What is the value of mu r by c? Refer figure 13.3. Yeah, is it 3.6? 3.5? So mu r by c, what do we go with? 3.5? If you think you are getting 3.6, go ahead with 3.6. So r by c is known. What is the value of mu? Multiply it with c by r, 0.001 to get mu as 0.0035. Now mu is known, w is known. What is the velocity? And so what is heat generated? Is the heat generated you are getting 1.4? Is that the value of heat generated? Okay, this is velocity 1.431. Give me the value of heat generated. Two one three kilowatt. Please check your value. 17.15. This is correct. Watts. This is in watt, right? Okay, now heat dissipated. Check for the formula of heat dissipated. It's again given in the design data book. Page number 126. which is equal to K. For good ventilation, the value of K is given into A. There is the projected area of the journal into TB, temperature of the bearing, minus ambient temperature plus 18 degrees. Where of this, where TB is again given, it's TB minus TA is equal to T oil temperature minus ambient temperature by 2. So oil temperature, I assume 90 degrees, ambient temperature is given, get the value of TB, substitute it here. And the projected area is L by D. Yes?
Ma'am, what is the page number for the formula?
Page 126. Table number 13.1. Got it?
Yes, ma'am.
Area is L by D. Give me heat dissipated. You are assuming the value of K for good ventilation, 3.67. Watt per meter square. Get 73. Please check your value. $29.3. Why so much variation? 3.9, 73, 29. K is in watt per meter square degree centigrade. Make sure area is in meter square. K is taken as 3.67. You all are getting 29.3. Go with this. 29.3 watt. So you see heat dissipated is more than heat generated. Isn't it? So do you think for this L by D, for this area, external cooling is required? No. So it is not required. No external cooling is required. If it is not well ventilated and if the value of HD comes out to be less than 17.3, then external cooling is required. Next is we have to find out what is the oil flow rate. We have to get the value of Q, oil flow rate. SAE grade 40 will maintain a viscosity of the required value up to 90 degrees. Beyond 90 degrees, its viscosity will change. So that is how we assume or we interpret from the graph. If you want for a given viscosity the different temperature, then you have to change with the SAE grade. Okay. Okay, what is the next graph wherein you will get, so Sommerfeld number S is known, we have to get the value of Q. So we'll be using the graph given on page 137, figure 13.6. This is the graph which is plotting oil flow rate Q on radius R, clearance C, speed bearing N, length of the bearing L versus Sommerfeld number. So it's meter cube per second upon meter cube per second. So this becomes dimensionless and Sommerfeld number S is dimensionless. So all these graphs, as I said, they are plotted for dimensionless numbers. We have to use consistent units. So for Sommerfeld number, 0.1516, whatever we have taken. For L by D, 1.2. From this graph, what is the value of Q by RCNL? Others, please. 3.8, 3.9, 4. Okay, whatever closest, 3.9. Let's go with 3.9. Everything is known. R is known, C, N, L is given. Give me the value of Q. Give me Q in meter cube per second or millimeter cube per second.
Ma'am, what is N?
N is RPS. Speed in RPS. Converting 450 RPM to RPS is how much? 7.5. And we 7.5. Tell me, what was the confusion? Give me Q. What is Q? Divakar, give me the value for oil flow rate. And 895. Yes, 1895 mm cube. Okay, so this is in millimeter cube per second. Let us check for how much oil needs to be supplied if there is a leakage. So this is to be the oil flow rate to be supplied for no leakage. This is oil to be supplied assuming no leakage. Now L by D is only 1.2, which means it is not a very long bearing. And so there has to be some side leakage. So if QS is side leakage and if Q is the oil flow rate, you have another graph for QS upon Q versus Sommerfeld number. So I'm extending this problem so that you get to know each and every graph how is this to be used. This is figure, which figure? 13.7, page 138. QS versus Q, where QS is the side leakage of oil. Give me the value. Oh, is there some printing mistake there? On the y axis, what are the values given? My book is giving 0.1, 0.2. It is 0.1, 0.2, 0.3 likewise. So with the smaller bearing with L by D 1 by 4, the side leakage is maximum. And as you move from L by D 1 by 2, 1, 2, and as you go on increasing, the side leakage reduces, which we have discussed for short bearing, the side leakage is more. So after 0, it is 0.1, then it is 0.2, 0.3, 0.4 likewise. So what is the value of sum of QS by Q? 0.55. Somebody please confirm. 0.55 or 0.58, okay. So almost half of the oil is leaking, isn't it? So what is oil leakage? What is the side leakage? 0.5 times total Q, oil flow rate, which happens to be how much? Okay, half of it, whatever value you are getting. One zero four two 1041. This much is the leakage, and if this is continuously leaking, this much oil should be continuously supplied. This is the total oil supplied, assuming there is no leakage, and this much amount of oil should be continuously supplied because this much amount of oil is leaking. So 1042 cubic millimeter per second, this much amount of oil needs to be supplied continuously. To maintain the oil film. So before we go for the next question, let me quickly recap this problem. What is oil flow rate? Oil flow rate is the amount of oil which needs to be supplied for hydrodynamic lubrication. You have to maintain a minimum oil film thickness. So if you supply this much amount of oil and if there is no leakage, then the hydrodynamic lubrication is maintained. But since our L by D is close to 1, which is not a long bearing, So there is a leakage, and because of leakage, the amount of oil will not be sufficient to maintain the hydrodynamic lubrication. So we check what is the side leakage, and if there is a leakage, that much oil needs to be continuously supplied, because this is a journal bearing and this operates only with oil. Yeah, so amount of oil that we have calculated just now, this needs to be supplied continuously. If there is no leakage, then the same amount of oil is sufficient. If no leakage is possible, whenever L by D ratio is large enough and within that length, the oil is continuously reused or circulated. Is that clear? Prajwal, Amey? Okay. So this was the problem where diameter is given, speed of bearing is given, load is given, minimum oil film thickness is given, and the temperatures are given, radial clearance ratio is given. We are required to find out the oil heat loss due to friction, comment if external cooling is required, and the oil flow rate. So we started by assuming an L by D ratio. You could have assumed L by D 1, and accordingly the values would change. Now, we do not have standard formulas, but we refer to the graphs which are plotted by performing large number of experimentation between the dimensionless parameters. So there is a standard dimensionless parameter which is used for journal bearing, and that is Sommerfeld number, which is given by Zn by P into R by C whole square, where this capital R, small r is same. It's all the radius of the journal and small d is diameter of the journal. Since H minimum is given, we can use the graph of Sommerfeld number versus H minimum by C for this L by D ratio to get the value of S. And from Sommerfeld number, where all other variables are known, we can get the value of viscosity Z. Keep in mind, because this is dimensionless, everything is in consistent units, you will get the value of Z in Pascal second. And the graph of viscosity versus temperature for different SAE grade of oil, this is giving the value in millipascal second. So this comes out to be oil SAE 40. Then to measure the heat generated because of friction, we need the value of coefficient of friction mu. So we refer to another graph which is mu R by C versus Sommerfeld number. R by C is known, S is known, so we get the value of mu. Mu is known, W is known, velocity is known, so we find out what is the heat generated. From the formula given, we find out what is the heat dissipated. And since for this much projected area A, heat dissipated is more, no external cooling is required. Suppose your L by D ratio is something different, the area would be different, and if this is less, then the heat dissipated might come out to be less than heat generated. And in that case, you have to comment that external cooling is required. Similarly, for oil flow rate, we refer to another graph which is given on this page number, which is the graph of Q by RCNL versus Sommerfeld number. S is known, so we pick up a graph where maximum variables are known and only one variable is unknown, so that we find out what is the oil flow rate. So this is the oil flow rate required for hydrodynamic lubrication, assuming no leakage. But here, for this L by D ratio, we found that the side leakage is almost half of the total oil supply. Okay, I'm coming to that. So from the side leakage, this much amount of oil needs to be continuously supplied. There are chambers wherein the entire bearing can be water cooled or it can be oil cooled. So that water or oil will not mix with this lubricating oil, but it is provided in a jacket and it is continuously cooled. That is external cooling. Okay, Sarthak? Still air and good ventilation is, still air is the normal air in the lab or in the room or in the experimental setup. Good ventilation is when the air is continuously flowing and moving, or it is being circulated with the help of fan or with the help of exhaust. So with good ventilation, more amount of heat would be dissipated. So you see the value of K for good ventilation is more than that of still air. So still air, as the name indicates, air is not circulating continuously. Good ventilation is external source, yes. So the place is windy or there are a lot of exhaust fans installed, and so you say it's a good ventilation. If the place itself is windy with lot of windows and ventilators and doors, or if the entire setup is kept in open air, even then we can call it good ventilation. Okay, any more doubts or could we go for next week? Let's go with the next. It is just mentioning that it is in good ventilation. Now there might be an exhaust fan as an external source, or the entire setup is kept somewhere where the air is moving. Oil being circulated is if we are supplying oil continuously, which is an external source of oil, then it is at the ambient temperature. If the same oil is circulated and if there is no side leakage, then it is circulated at whatever higher temperature it is. But the heat is getting dissipated, which means the temperature of the oil is sufficient to make sure that whatever amount of heat is generated, equal amount is dissipated. I request all of you to post your questions in general group instead of posting it privately, so everyone gets to know which question I am answering.
Ma'am,
Yeah, please.
ma'am, will the total oil flow rate be Q plus QS?
Q plus.
QS.
Yeah, total oil flow. Yes, you are right. So as I said, this much amount of oil is continuously supplied 1042. This is leaking and it is again we are freshly supplying. So this is like a continuous loop. And if there is no leakage, then with that much amount of double of this amount. So you initially supply the oil and because of leakage, 1042 is continuously supplied. Okay. So next question, feel free to ask me more questions if you have any. A 50 mm journal. This is now a different type of question, which is ground. Ground is grinding. So from grinding as a manufacturing process. Is running in a lathe turned bearing. Is running in a lathe turned bearing. So the bearing is prepared or manufactured by lathe turning and the journal is prepared by grinding. So it is telling about the manufacturing process from which we have to find out what is the surface roughness at a speed of 600 rpm. Length of the bearing is 60 mm. So here L by D ratio is known. Diameter is 50, length is 60. The bearing is supplied with oil SAE 20. And the optimum temperature of the oil is 65 degrees. If the bearing is to run hydrodynamically, what is the maximum load carrying capacity? What is the load carrying capacity? Also find if the ground shaft or the ground journal is replaced with lathe turned shaft. Depending upon the manufacturing process, the surface roughness would change. What happens to the load carrying capacity? Whether it increases, decreases. Also, if the clearance increases by 25% after refurbishment, what is refurbishment? What is the load carrying capacity? Clearance ratio is given as 0.001. What do you mean by refurbishment? Yes, after repairs, after overhauling, or after servicing. So after servicing, when it is cleaned, the clearance would increase. So L is known, D is known, so L by D is also known. 60 by 50, 1.2. D is known, so R is also known. And from R by C ratio or C by R ratio, clearance is also given. What is the value of clearance? C by R is now 1 upon 0.001. R is 50. Give me the clearance C. And for 65 degrees optimum temperature for SAE 20 oil, give me the viscosity from the graph. Graph is giving millipascal second. Give me the answers quickly, please. Give me C, give me Z. R is 25. D is 50. C is how much? 0.05. Z is, are you getting 20? Exactly? 0.05 है, 0.025 है C. It should be 0.025. Z, viscosity, you're getting is 20. Okay. Now let us try to get H minimum. And how to get H minimum? H minimum is, this is the journal, this is the bearing. Say this is the H minimum value. Now the minimum value of H minimum has to be greater than whatever is the surface roughness of this journal and roughness of the bearing. So we'll find out what is the roughness for lathe turned shaft and what is the roughness for a ground shaft. So you have to refer table 3.8, page number is 53. Design data book, B.D. Shivalkar, page 53, table 3.8. Table 3.8 and 3.6. What is the average RMS value in microns for lathe turn shaft? And for cylindrically ground shaft. So you see that average RMS value. This is the surface finish obtained for lathe turned. Average RMS value is 0.75 and the range is given. Similarly, for the ground shaft, which is cylindrically ground, so it is circular in shape and hence it is cylindrically ground. The value is 0.25. Now this is the roughness. This is the surface finish or the surface roughness. And next table 3.8. So this you got from table 3.6. From table 3.8, what you get is the peak to valley upon RMS. Peak to valley upon RMS. Again for turn and again for ground. What is the value? Valley, if this is a material, this is the roughness in an exaggerated way. These are the peaks, these are the valleys. These are the peaks. So for the turned shaft, it is 5. For the ground shaft, this ratio is 4.5. So give me what is the peak to valley roughness for turn shaft and for the ground shaft. This is peak to V by RMS. RMS you know. So give me what is the peak to valley ratio for the turn shaft. This will be 5 into 0.75, right? And similarly, the peak to valley ratio for the ground shaft. Oh, my handwriting is coming out to be horrible. 4.5 into 0.25. Give me the values. .75 for turned, and for ground it is 1.125. I'm so happy today with the answers that you are posting. Okay, so what should be the minimum film thickness to avoid this contact? Sum of these two. This should be the minimum value, so it has to be more than this. So sum of 3.75 plus 1.125. Which is how much? 4.875 microns, micrometer. You got this? So this is for the shaft, and likewise here we have this bearing. Bearing is also having some roughness. So the maximum peak to valley height of this and maximum peak to valley height of this. So this has to be the minimum oil film thickness. And we always want this H minimum to be maximum possible. But this cannot be less than this. So we go with 4.875 as H minimum. And now from H minimum by C, let's get the Sommerfeld number. Find H minimum by C and get the graph for Sommerfeld number S. So from Sommerfeld number S, we have Z value, we have RPM. We will get average pressure, and this will help us to find out what is the load carrying capacity from S. How much you got? H minimum by C? 4.875 upon 0.0025. Give me H minimum by C. Point 195. This is in micrometers, C is in millimeters. This has to be dimensionless, so make sure your units are correct. So for L by D, 1 by 2, 1.2. Give me S from the graph. Check if you are multiplying with 10 raised to minus 2 or 10 raised to minus 1. Riddhima, convert micrometers to millimeters. Utkarsh, 195 or 0.195? Utkarsh. Ambika, 0.3 is S. 0.195. Ambika, are you getting 3 10 raised to minus 1 or 3 10 raised to minus 2? Yeah, it is 0.03. It is 3 10 raised to minus 2. Is it 3 or is it 4? Is it close to 4? It's close to 4. Yeah, so it is actually 3.8 10 raised to minus 2. Or 4 10 raised to minus 2. Okay, so whatever value you are more comfortable with, let me go with Vineet, who is saying 0.038. So you are getting a value 3.8 10 raised to minus 2 for this value of H minimum by C. I know it's a lot of approximation, so 0.038 and 0.04 both are okay. So with this value of S, Z known, N known, R by C known, give me the value of pressure, and this pressure will give you the load carrying capacity. Give me load carrying capacity. What is average pressure? Give me average pressure. दायित्व हर्षिल शिवेश Ujjwal, Anshuman, give me answers. .26. This is what? 5.79. This is load or pressure? MPa, pressure. So what is the load carrying capacity? Multiply it with L by D, L and D. Multiply it with 60 into 50. You should get around 16, 17. Tejas, give me the answer. .4. Right. This is the load carrying capacity. Do we have 5 more minutes? We'll finish up this problem. First part is saying that if the ground shaft is replaced with the lathe turn shaft, allow me to go back. So instead of ground, if both are lathe turn, so if bearing is lathe turn and shaft is also lathe turn, which means the peak to velocity, peak to value ratio is 3.75 and 3.75. What will be H minimum now? H minimum will be 3.75 plus 3.75. If it is turned to, if the journal or the shaft is also lathe turn, then the value of H minimum will be 3.75 plus 3.75. So the moment H minimum changes from the graph of H minimum by C versus Sommerfeld number, S will change. The moment S changes, your average pressure would change, load carrying capacity would change. So this is ultimately what happens from the ground shaft if it is converted to a lathe turn shaft, how the load carrying capacity changes. Whether the load carrying capacity increases or decreases, this is what we have to see. And in the second part, as the clearance increases. What does part 2 says? Part 2 says that what if the ground shaft is replaced with a lathe turn shaft? Shaft is same as journal. So initially we are assuming that the journal is ground, and now we are assuming if it is turned on the shaft. So if by turning operation we are using, then from the RMS value and peak to valley ratio, we are getting the peak to valley ratio as 3.75 for both, for journal and for bearing. And so now H minimum will become 3.75 plus 3.75. Got it, Tanvi? Yeah, okay. Similarly, if C is increased by 25%, clearance is increased, Assuming the same value of H minimum that we got here, 7.5, your H minimum by C, this would change, S would change, again pressure would change, load carrying capacity would change. So we have to see that with increase in H minimum, what happens to load carrying capacity, with increase in C, the clearance, what happens to the load carrying capacity. Are we solving it now? Are you giving me the answers now? Are you giving me the answers now? For this H minimum by C, what is S? New value of Sommerfeld number? 2.86. What is the load carrying capacity? 8.58. Pradyuma, you are giving me answer for this.
Ma'am,
Yes?
ma'am, will the R by C ratio change in the second part or not?
Yes, it will. C is changed, so R by C will also change. So that was the value of R by C when the bearing was new, and after refurbishment, now the clearance has changed. So R by C also changes. What is the value of S you got here for this part, for which you are getting pressure as 2.86? What is this Sommerfeld number? Pradyumna? 0.07. Okay. My value is 0.06, for which you are getting. Yeah, others, please confirm your answers. These are the answers from Pradyumna. This is 2.86 MPa, for which the load is 8.5 kilonewton. Ujjwal, you are getting 0.058 as S?
Yes, ma'am.
Okay. Okay, so for whatever value you are getting, give me what is pressure and what is load. Likewise, you can do it for second part. So accordingly, the questions will be modified. We keep on changing the parameters. Ujjwal is getting 3.8 and accordingly 11.4. Okay, this seems to be more proper. We'll solve couple of more problems on journal bearing in this Saturday's lecture. That would be end of this journal bearing topic. So next week we'll start with rolling contact bearing, which is ball bearing and roller bearings. I cannot force you or compel you to come and attend the physical classes because it is Corona is still not completely zeroed. We do have few cases in Nagpur every day, but I can definitely request you to come in physical mode from Monday. We will definitely enjoy interacting on this topic in physical case. Utkarsh is getting 0.07. It's okay with whatever value you are getting because there is always some error. We don't have an exact curve for L by D 1.2. So whether it is 0.07 or 0.06, that is your assumption. So 0.058 is 0.06. So you can please go ahead with your own values. With a hard copy of the design data book, you can be more accurate as compared to the soft copy. Yeah, I want to take offline classes, but at least we should have a strength 100 plus. If there are only 25 and 30 students in the class, then there's no point in taking offline class.
Ma'am, is the Shivalkar data book is allowed in the exam, or the data will be
Yes.
provided by you?
No, it is allowed in the exam, very much allowed.
Okay, ma'am. Thank you.
PSG and Shivalkar, both the design data books are allowed. But mobiles are not allowed, as you know. Little beyond 1, yes. L by D little beyond 1. So Saturday, again online lecture. Tuesday, looking forward to have lecture in a physical mode. Okay, so we'll stop here. You can complete this problem and post the answers in the group. Thank you.